I don't know why Zoom acting like that. And I don't think I put restrictions on y'all that y'all can't talk in here. 'Cause that kind of defeats the purpose. Let's see, advance.
Hey, drop the link to the survey
Yeah,
in
I
the
don't
chat
hear
too.
anybody. That's crazy. Dang, why can't I hear then? Let me do this. Somebody say something.
Yo, yo, yo.
Oh, I'm tripping. It's me. It's me. All right, hold on, just a second. It's user error. All right, say something else, Phil.
Yo, yo, yo.
Bro.
Okay, there we go. The
Oh,
accent wasn't your accent. I think they were talking about the Trump accent.
oh, the Trump.
I
Oh,
think that's what they were
oh,
referring to.
making it great. Okay.
That's why I followed in with, the absolutes. To be honest, America has been great. You guys have just not been great with America. Okay? Listen, there's one thing I love more than Americans. That's white Americans.
No.
All
Oh
right, I
my
won't do that.
god.
I won't do that.
Oh my god, bro.
All right.
Oh shoot.
And Teslas and Doge and yeah,
and
yeah, never
and
mind.
shaking babies and
And
kissing
shaking
hands.
babies and kissing hands.
No, we making America great right now.
Yeah,
Training,
absolutely. Absolutely.
sequel.
Shout out to Christmas Mang,
You
C4,
know
if
what
you
I'm
may know
saying?
him that way, Chris Martin. However you know him, shout out to him one time for doing this because a lot of us could use this knowledge and you don't really see a lot of people out there just handing this information out there for free. So we appreciate it, bro.
No, for sure. Yeah, yeah, no problem, no problem. I'm glad to do it. Let me let this person in. So yeah, yeah, I think we're good. We can move forward. Uh, so I'll just give a little background on myself real quick, and then what we're about to do, and then the data diva herself, if she has a word,
Oh,
I'll
this is your event. I'm just hosting. The floor is yours.
okay, there it is. There it is. I appreciate you a lot. Like them seats got filled quick.
For sure. This is your
So yeah,
platform as well. It's for the community. So if anyone is wanting to step up as a mentor and has any type of resource and they're expert in their field and they want to help and give back, just reach out to me and we'll get an event set up for you and we'll put it out to the community so everybody can join.
there it is. Appreciate it. Appreciate it. That's big. That's real big. So all right. So about me real quick. So back in what I started school. I started college in like 2004. Went to Georgia Tech. Transferred out of there. Went to Auburn. Got a degree in chemical engineering. So then did that for like 6 years. So working in a plant, stuff like that. Switched over into the tech side of stuff because like that's just where stuff was. That's where the opportunity, the money, the growth, all of that. And it was to me more interesting. Like doing the stuff on the computer, there's a quick turnaround. Like there's just so much stuff you can do. You know what I'm saying in the tech space, in the data space specifically. And there's so much stuff that like companies need, and it's just a wide open area of opportunity, and it interested me and I enjoyed doing it. So I started learning Python, SQL, machine learning stuff, all kind of different stuff. I just did a deep dive into all of it, and that was beginning back in 2016. So next year I'll be able to say, I got a good 10 years experience in it. Yeah, like next year, which is going to be big because another thing, just a real quick career thing, like the formula of deciding pay, years of experience is a crucial part of that. So I'm looking forward to it. And yeah, we want to I just want to, give back to people who are trying to get there and stuff. So Yeah, so I that's my experience. I've been doing SQL pretty much the entire time, and Python and data engineering stuff. Did some front end stuff, so a little bit of JavaScript, TypeScript, Angular framework type stuff. No React or anything like that. That's just because of the jobs that I held. So I just used whatever technology that the job had, and it turned out to be Angular. But it helped teach me TypeScript in the process. So with that, we'll go ahead and get started. And we'll go for a while, and then we'll probably, because this is a 2 hour thing, right? So like, we're definitely gonna need to take a break or two. So we'll do that shortly. And also, I am going to record to cloud as well. So there'll be a video that you'll be able to go back out to and reference. And also, there will be a GitHub repository. I will share the link to that. And there will be a survey that you all can fill out to kind of help with improving future sessions, because there will be future sessions. All right. So I'll unpause this recording.
Real quick,
Yeah.
as you go through it, could you maybe for those without the without the level of vernacular, uh, kind of go through in detail on some of the stuff that you're explaining as you do it, if you don't
Oh
mind,
yeah.
please.
Yeah. Absolutely. Yeah. Yeah. And
Because
that's why I also
anybody,
called. Oh, go ahead.
I was gonna say anybody that is stringent in that front, that they can, have a little bit of, maybe detailed on that, so they're not, because you said you're gonna mute it while we're going through it, right?
Um. Oh no, no, no. I'm recording, and then
Right, right. But you're gonna mute the rest of us, so no one would be able to.
Oh no, 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 no. I'm asking you to go on mute, and then like if you really have a question, come off mute and you can ask. I'm not forcing everybody to mute though.
Okay, makes sense. Makes sense.
Yep.
All right,
Yep.
I'll fall
Yep.
back.
All right. I'll share my screen here, and not that one, but this one. So if you go to the website that I posted in the chat, the Programmy's SQL online compiler, you should be met with the same thing that I have here. And it might have some different, matter of fact, let me refresh this. So this is exactly what you should see. An online editor, it has a couple comments, has a query here that you can run. To run the query, you hit the run SQL button for this particular interface. The layout here is on the left side. They basically have the description of the data set. So it lists the tables, all of the columns in each table, and then the type of data in that table for that particular column. So customer ID in customers table. Int is short for integer, which is your typical number 1, 2, 3, 4, 5, 6, 7, 8 whole numbers, -1, -2, -3, so on and so forth. Varchar, that's character data, so strings, words, letters, that type of thing. And let's see, do they have any? They just do those two in this particular set of data, but there's other data types like Boolean, which would be a true false. There's decimal data types or numeric, where instead of an integer is 1.77539 whatever. But that requires a different designation than the integer designation. So, but that's a little bit about the left side here and understanding what the data is. And going over onto the right side, we have the tables with the actual data. So again, this is why I like this website, because they have some tables here and it's real simple tables. So a customer table is a few columns and then a few rows of data, easy to digest. Orders, and then shipping. So you can kind of imagine this is like a data set for like a maybe an online store where they sell some computer peripherals, and they ship them out once the customers make the order. And looks like it might also be international, so you can kind of glean some things just from the data set itself. So now we'll actually get into doing some actual SQL code. So what I'm gonna do is I'm gonna erase all this, and I'm gonna go over the most basic aspect of SQL. The first keyword to know is select. And with pretty much any database system that you're using that uses SQL, you'll be able to do something like this. Select one or any number. It doesn't really matter, but select one. If you run this, this will execute and it will give you a result where it has the column name and the actual value for that column of the results of your query. You can do this all day, every day on just about any SQL system. Select and then some sort of literal value, and that will run all the time. You can also do multiples. So this is, I want 2 columns of data. Maybe I don't want the number 2, maybe I want the number 89. Run this, boom. It defaults the column name to the actual value and then gives you the actual value on the second. This second row is actually the first row. These are the column titles on top. So this is like the header up top and the rows on the bottom. If we want to make this a little bit cleaner, you can alias your column names. There's another keyword here called as. So I might want to call this number 1, and this is the second number. Put as in there. Run that. And now you see I got a real header that actually has a description that makes sense, or that could make sense depending on what I call it. And then the results are under the header. You don't have to just do numbers. You can do words too. So I can do this, run that, and boom, I get a new field with this as the header name, and this is the value. Now, also, you can alias that, run it, and now we got our headers and our row. Any questions, any concerns right there? Everybody following that? That you can just run select and then select the thing that you want. Also, you can format this kind of how you want it. This is not like Python where the white space actually matters. You can write entire SQL queries on a single line, but good luck reading that. So what we tend to do is like, you know, take select and then put the fields under it and kind of give them some spacing, you know, kind of like that. So it's like select and then these columns down here, and then you give them their names and all that. You can do math operations in this as well. So if you want to add some numbers together, you can do that. If I do this, 1 plus 2 is in fact 3. I can call it, I can give it a name for the column. And that's it. Really straightforward. Some of the keywords in SQL are optional as well. This will take time to get used to. I think it's best to be as explicit as possible, but sometimes if you're trying to do something real quick, you may end up with something like this. And basically you can leave out the word as and just run the SQL like that, and then boom, addition 3, it gives you the same result. And then if I put my name back, call it first name, run that, it still gives you the same result. So that's like a little tip there, because you might see somebody else's query. So this is twofold. It's so you can write your own queries, and also so like you can understand other people's queries too. So that's where we're at. And then I didn't put the colon, but normally you put the colon here because let's say you have multiple let's say you have multiple queries written on the same page. The colon set tells the SQL interpreter like this is one query, this is another query. If I don't have this, this will run into problems. It's saying, hey, this is a this is an error because it's trying to run this as one query when it's actually two. And let's see, we have a question here. Why does SQL deem it as an error if you do first underscore name instead of first space name? So it's mostly true what I said earlier about the white space. When it comes to labeling things, like if I want this value for this column to have the column label, it's going to think that I forgot to put a comma here if I do this. So it's going to see Chris is named first, and then it looks like you're trying to select something called name, but it doesn't exist. So let's run this. Yeah, so error near name syntax. But to correct that, SQL differentiates between single quotes and double quotes. So if you really want that to be like that, you can put double quotes, and it'll group this together as one single label column name entity. And you see I get first space name. So this gives you the ability to kind of format the column names if you want to. So does everybody understand that? Any questions there about just using select by itself? 3, 2, 1. Okay. All right, so we can move on to actually querying data from the actual tables, which is the fun part. So I will show you the first kind of little shortcut. Let's say I want to select all from the customer table, like select everything from the customer table just so I can take a look at it. Because in a normal database system, you're not just going to have the table sitting here for you to look at like that. So sometimes you just want to see what's in the table so you can start understanding. And if you want all columns, you do not have to type every single column by itself, which is great. You can use this symbol, use an asterisk. This is a shortcut to say, give me everything. And when people read this, you just read it as select all. And then we're going to say, introduce our other keyword here, from. From precedes whatever table or subquery, but we'll leave subqueries for another time. In this case, tables. So we have a table called customers. And if I type customers here, put my colon, run this query, it just regurgitates all of the data that's in this table. And this is really that simple. Like, just select all from customers and boom, run that, get everything from customers. Now I will give you this warning. Enterprise data, the company might have a table, their customer table might have, 100 million rows in it. And when you do this is going to send all that data over the network to your computer. And when it's doing that, it's going to bog down the system. And the administrators are going to be able to see that, hey, user such and such just did a select all on this ridiculously large table. And now other queries are running slow, blah, blah, blah. So if you're going to do this on only small data sets and really just kind of stay away from it, or do a thing that I'll show y'all later where you can limit the results. There's a keyword called limit, but we'll go over that a little later, where you can limit results. But I just wanted y'all to see that you can select all the columns from a table using this symbol. And then if there's some other stuff, like let's say you have a calculation, you can select all from this and then do your calculation off to the side and you run that and it'll add that as a column to your result set. So you really have a huge level of control over what to include in your query. So now we don't want to do everything. We want to select some specific things. And basically, how you do that is after select, you can write out each column and separate it by commas. So let's go first name and country. And again, these don't have to be on the same line. You can format it like this. We run this. This gives me everything from the customer tables, but just these two columns. So that's how you can start getting real specific as to the things you want from your query. Now I'm gonna go back over the labeling thing. So let's say we want last name in there as well, just to get a small glimpse of our customers. So we got first name, last name, country. But let's say I don't like the labels, so I give it this label. Matter of fact, let's be real official. Just proper case everything. Last name, and then country. Country is fine. No, I want a capital C. Yeah, let's be consistent. So I'll write my query like this, and actually this doesn't need the double quotes since there are no spaces. You basically need the double quotes if you got spaces in your column name that you want. Run that, and now I have like a real official looking output table. Like this is something, could go in a report or something. So that's how you can do your queries and label everything and make it look nice and all that good stuff. Oh, matter of fact, I got a better example. Let's say we want to get real specific. Double quotes allow you to do stuff like this. So see, I could add that single quote in there for person's country. So you get that formatting. So another thing here is when usually you can see like in a report or something, you wouldn't have a first name column or a last name column, not for real. There is this thing called concatenation. Okay. And with concatenating things, concatenation. When you concatenate things together, that's just basically just slapping them together. Put two things into one thing. Make two things into one thing by joining them together. You can do that in SQL. The operator for that is the double pipe. If you know how to program, this might look like the OR symbol. But with the double pipe symbol like that, you can concatenate strings together. So here I want, instead of first name column, last name column, I want the first and last name together. So yeah, let me do it up here. If I do this, that's gonna put the first and last name together, and then I can just call this column name. Run this. Now, if you look at this data, you see there's a little issue. It slapped them together all right, but there's no space between the first name and last name. But that's an easy fix because we can single quote, add in a space, concatenate again, run this, and look at that. Beautiful. John Doe, Robert Luna, everybody else. And we have our formatted name field result. And we just basically concatenated first name and last name together to produce this. Any questions there? Okay. Now
I have a question.
Yeah, go ahead.
Can we just do the double space? We don't have to put the concatenation, right? We can just do the two lines, parallel lines.
Oh, you saying like this?
Yeah.
Yeah. I mean, yeah, you can totally do this. Well, let's run this again, and you see how the thing. But like, if you, there could be a reason to do that, though. So it's completely up to you. like I could, instead of doing a space, I could do hyphens, right? And now it's John hyphen Doe, Robert hyphen Luna. You have some freedom there, and then you can concatenate as many things as you want, right? So now I just put something else on the end of everybody's name, so you can get as crazy as you want with that. Um, it's just that, just remember, like, think of this as the plus sign for numbers. So 1 plus 2 plus 3. It's like string concatenate to another string, concatenate to another string. And by string, I mean like text data. Okay. So that's what I mean by that. So running this, and this is what we see.
But do you see how, like, under you put the two dashes, then you put concatenation, and then the actual symbol for it? I'm asking, like, do we have to put that on the bottom under where you put from customers?
Oh, this?
Yeah.
Oh, okay. Yeah, I'll talk about this. This is just a comment.
Okay. Okay.
Yeah, that's all this is. This is just a code comment. So I just put that there to explain. So yeah, if I take this off, this still runs just fine.
Okay. Thank you. That's all I'm gonna know.
Yeah, no problem. I understand. I get you now. Yeah. Chantel, you have a problem? Not a problem. A question. And did I say your name right?
Yeah, you did, Chantel. So my question was, is there ever a time where you have to go above double quotes? Like if you want to have more than two, you know what I mean? So like to differentiate them, you do single quotes, you do double quotes. Is there ever a time you have to go above that, or you would just have to code it differently? Does that make sense?
I think what you're asking is about like escaping the quotes.
No,
Um,
like if you for data, so
oh,
you'd
sorry.
have to differentiate another column.
Can you put a like trying to walk me through an example, I guess.
Use the double quotes so that you can differentiate the name one row from the
Ah,
person's country. If you had
yeah.
a third row, how would you differentiate that from the previous two? Is my question. Like
Oh,
if
if
you
I had
wanted
like another column basically. So like
their
if I brought
order
in
something, you know, yeah, another column.
okay. So like if I wanted to do this, oops.
Yeah. So you would just do double quotes again, and you don't have
Yep.
to go.
Yep. That's right.
Okay.
Because each column separated by the commas is independent.
Oh, okay, understood. Got it.
Yeah. Yep. Okay. Gotcha. No, that was a good question. So yeah, basically, if I format it like this, it might be a little easier to see. So we got select, and then we have, this is our first column of our result. This is our second column of our result, and this is our third column of our result. And you can name them using, you can use the double quotes if you need to, because, you have spaces or whatever. Or if you don't have spaces, you don't have to put the quotes, and that still runs perfectly. So yeah, it's just a bunch of optional things to be able. It's just more than one way to label a column, if that makes sense. But yeah, it's not a hierarchy per se. Um, let's see. Okay, if there aren't any more questions, we will add um a new concept here. So I run this SQL. I get, the names, the country, the age. You can sort the data depending on how you need to do that. So let's say I wanted these people youngest to oldest. I would do that. No, actually, no, not youngest to oldest. Just the names in alphabetical order, right? So if their names start with A, put that at the top, Z all the way A through Z at the bottom. So there's a keyword phrase, order by. And then you just put the column that you want to do the ordering by, and that column is first name. And you run this, and look at that. We got Betty first, David, John, then Robert. Alphabetical order. If I wanted to do it backwards, where Robert comes first, you add one more keyword here, DESC. That's short for descending, because ascending is the default. If I run this now, Robert comes first, and then so it's basically Z to A. Does that make sense? So that's how you order data. And you don't have to order on just one column either. Let's say you got if you look at it, we have 2 people from USA, 2 people from UK, and 1 person from United Arab Emirates, right? So let's say within these kind of subgroups, you want youngest to oldest. Now it looks like, nope, it's not youngest to oldest across the groups, basically. So we got the younger person, then the older person. Then we got the older person and the younger person within the UK. Let's say I want to do that where it's always the youngest to oldest. I can add a second column to the order by statement. If I run this, now it didn't order by person's country. Oh shoot, I would have to, you know what, that's a whole different thing. That's a whole different thing. I would have to order by the country as well. So let's do that. Because the whole point of showing this is that you can do multiple columns on ordering. It just says, this is basically saying order by this first, then by this, and then by this. So let's see, we got our first name, descending, and it grouped everybody in a really weird way. Let's see, I think, do I need to do country first? So this is just about kind of what I was looking for. Now, the names are also sorted based on the country. So we're getting this result. But the point is, you can order on multiple columns and get different results depending on what your needs are. You just might have to play around with it. So these UK people, here's the youngest, oldest. USA people, youngest, oldest. But the names aren't in order. Because I think what it is conflicting with the ordering of the name versus the ordering of the age. So I'm not going to be able to get exactly what I'm looking for without, because it's not that the youngest person is also the first in the alphabetical order. So yeah, that's why. But yeah, this is like you can order on multiple columns. That was really the whole point. Let's see. What do I want to do next here? Any questions on that? All right. So, yeah, no questions. All right. So now I'm just going to order on age right quick. So now I just have my single sort. I have each person, youngest to oldest, period. Now, sometimes you may want to filter. So what we're going to add now is the ability to filter on these results. So here is where the where clause comes in. Where the where clause is for filtering. It does come before the order by statement. So towards the end of this session, we'll talk more about like the order, like it's select from where and then order. But let's say I want the age, everybody over the age of 25. So 25 and up people. That's what I'm interested in. So I would say where age is greater than or equal to 25. I run this. We can look at the data and tell these two rows, they shouldn't belong, right? So we should only expect these bottom three. So I'll run this, and that's what I get. My 25 and up crowd in the results. And that's how you can filter out stuff. Let's say I only want the people named John. I can go first name equal to the exact spelling of John in this query, and it only gives me the 2 Johns that are in the data set. Also, let's say I want everybody not named John, right? So I shouldn't go in there and type, okay, I want Robert, David, and Betty. Nah, you shouldn't have to do that. I want everybody, no matter who it is, except John. We don't like John no more. Get him out of here. So we run this. We put the exclamation point. So this means not equal to. Similar to a lot of other programming languages. So first name not equal to John, and this gives me everybody but John. Now, let's say I want a set of specific names. Well, you can do multiple conditions in the where clause. So let's say I want John, and I want David, and I want Robert. Run this. Oops. Run this. What did I do? From customer where first name is John and first name. Oh, wait. Nope. Not and. Wrong word. Or. Because nobody's first name is all 3 of those. That's why we can't use and. So if I run this, if your name is John or your name is David or your name is Robert, you come up in the result set. So basically everybody but Betty in this case. But yeah, that's how you can get you can kind of choose a set of criteria. Now, this particular repetitive syntax here, there's a problem here, which is we don't want to type all of this, right? First name equals this, and then, or first name equals this, and then first name equals this again. No. There's a better way. So I'm gonna show you the better way. But I wanted to show you this first of how to use or. So basically, if any of these conditions are true for the row that you're looking at, it includes it in the result set. But we can do better than this. If I take this out, put a comma. Take this out, put another comma. Put in a set of parentheses. Type this like this. So if we do, matter of fact, I'm tired of looking at that hyphen too. Okay, so this filter is saying the same thing of what I wrote previously. So here, first name, we're saying where first name value is in this set of values. If I run this, I get the same exact result. Everybody but Betty, order by age. And that way you don't have to say first name equal John, or first name equal David, or first name equal Robert, or first name equal something else, or first name blah blah blah. Nah, just get the results in a list like this, and you can just say mention first name once. Is it in these names? If so, add it, and then boom, we're in the game. Any questions there? So now we'll do another way of doing multiple filter conditions. So let's say I want everybody named John who is also older than 25 years old. So this time not greater than or equal to, but just greater than, who's older than 25. If I run this, it's only one John. John Doe is the only John in our data set that is over the age of 25. If I do the equal to, we get the other John who is age 25. Everybody following along so far? If so, put a thumbs up, or put a thumbs up, or do a reaction like JD Cruz. Appreciate it. How do you know when to put the semicolon? So the semicolon is basically a separator for queries, right? So like if I have multiple queries, I have some queries already written out. So I will show you those, what that kind of looks like. 2 hyphens make a comment in SQL, by the way, just so everybody knows. 2 hyphens, you can write whatever you want, and it's not going to try to execute that code. But I'm just putting this here to kind of separate out what we're doing. So if I paste these, so I got 1, 2, 3, 4 separate queries. If I run all of these, I should get 4 separate result set. Oh, I got a typo. Country. Run the SQL. So here's our first result set. Here's the second one. Here's the third one. Here's the fourth one. But yeah, so the semicolon is a separator for each specific query, so that it doesn't try to run everything as one big query. You kind of see that in JavaScript too. It's like each line of code, it says, okay, this line of code is one expression, semicolon. Go to the next line, it's a new expression. No semicolon, it thinks it's all one big expression, and then it tries to execute that, and you run into issues. So this is multiple, and you can keep going. Like you can add and just test out a bunch of different stuff with multiple filter conditions. And you'll see that a lot on the job too, where like you're trying to match up where like, okay, this column is this and this column is not equal to that, and this is this. And it might be, it could be 20, 30 different conditions that have to be met. But it just depends on the situation. Another thing is, so you can do equal to, you can do not equal to, you can do greater than, equal to, you can do less than, or equal to. You can also do another keyword called like. So I'll demonstrate kind of what that looks like. So let's say let's look at last names. So let's say we want the last names where the first letter starts with R. In order to do this, you need the like keyword and you need the you need the % wildcard character. What the % means is, or rather how to read this, what I just wrote is where last name like a string that starts with the capital R, and then I don't care about anything else that comes after the R. But the R has to come first in the string. If I run this, I get the 2 people who have last names that start with R. I can change the letter, get these 2 people. I can also do everybody that doesn't have a last name that starts like D. If I put not like, so I'll run that. So I get everybody who has a last name that doesn't start with D. There's a not like us joke in there somewhere, but my humor isn't good enough to make it. So I'm going to leave it alone. But yeah, this is last name not like the letter D that starts with the letter D. You do have to match the case. It is case sensitive, so I think I think this would give me everything. No, this particular interpreter isn't case sensitive, but some systems are. So just be aware of that. Like if they literally have a capital D in the data set but you put a lowercase d, you could not get what you're looking for. So let's see, this still matches. So it's not case sensitive in this particular system. Can you do %R? Absolutely. So basically, this is saying everything that ends in the letter R, because you're saying now the letter R is at the end of the string. So you can have whatever up front and then whatever's at the back. Run that. None of the last names end with the letter R, but one does end with the letter T. Let's see if it gives us that one, which it does. So that's how that works. Now, another thing you can do, I was just finna go over that one. So if you want to say, hey, my name contains, the thing I'm looking for contains the letter T, or let's do the letter B. It contains the letter B. So we don't care what's before the letter B. We don't care what's after the letter B, but just long as the letter B is in the word. And David Robinson's last name has the letter B. Let's do the letter I. That should give us some more results. So Robinson and Reinhardt, they both have I's in their last name. If we do an E, what does that give us? The two Does and Reinhardt. So yeah, this gives you can create whatever pattern in here that meets your needs, if that makes sense. So like they might at work, an example would be, okay, we have a code where the first 5 characters represent this, the next 2 characters represent something else, and the last 3 characters represent something else. If we have these 3 characters on the end, that means this is a XYZ product, and that's what we want to get out of that. So then we're like, okay, if the string ends in TION, that means it's a something or whatever, or XYZ. And those, I'll run that, and then that'll give me the list of whatever ends in XYZ. Will you work if you do, I think that's II or LL? Yeah, so if you do something like this, let's just make ZZ, right? What this means is you're looking for a pattern of where 2 Z's are sitting next to each other. You don't care what comes after the Z's. You don't care what goes after the Z's. You don't care what comes before the Z's. You are just strictly like, hey, long as it comes with those two letters next together in that particular string, and then that's what it'll look for. So that's how you use like. And then again, if it's like you want to exclude those, you just use the not keyword. So not like this. Any other questions about like? And you can really, you can put whatever pattern. Let's say it starts with the letter R, then there's some other combination of letters, but then there's also a ZZ in there, and then I don't care about whatever comes after that. Or I know that it ends in D. So this will match on Riz, Raz, Rosed, whatever the freaking word is, right? You're just saying it looks something like this. That's basically what you're saying with the like keyword. So any other questions there? Okay. Let's see. We did. Oh, let's do another or, because I showed you the or. If you do the or on the same column, that you could use the in keyword, but like let's say you're doing or on the different columns, you can do that too. So first name equals to John. I can't type John. Or last name equals Doe. If I run this, I get this set of results. So I got both people named John, and then I got everybody who also has a last name of Doe. So you can use the or keyword across different columns as well. There's no limitation on how you really use this. You just kind of have to think through your logic to make sure that you get the result you're expecting. And we expected this result because we have two people named John. We got two instances of Doe. One person has both. So you kind of expect three results out of that query. Another keyword here. This is a really good one because can you show an order by with this? So yeah, we're still ordering on age, but we can order by first name on this too. So yeah, the order by has been going ever since we added it. But let's change it up. So yeah, now we see, hey, we're ordering by this. We can change it to country. We can do country. And no, let's do first name and age. First name, age ascending. Run this. And we see that the Johns are ordered where the youngest John comes first, then the oldest John, and then Betty is by herself, so it just puts her. But if there was like another Betty, if she was older, she would be the second entry. Let's see. Now, now I want to show you a new keyword called between. So let's say we're looking at everybody in the customer table, but we want only people between the ages 20 and 25. Now, what you could do is say where age is greater than or equal to 20 and age is less than or equal to 25. This will give you everyone that is between the ages of 20 because the age has to be greater than 20, but it also has to be less than 25. Less than or equal to 25. So, yeah. So we got these three people. These three people are between the ages of 20 and 25. Great. Now, looking at this though, you're repeating the criteria on the age column again, kind of like how we did earlier with the names. That's where the between keyword comes in. So we can write this same thing and say where age between 20 and 25. I like this because it's a lot cleaner. It's literal English. Like it's really easy to read. And it's inclusive of the numbers that you put. So there, same three people come up because they are literally between the ages of 20 and 25. Any questions with that one? A lot of times how you see between get used is usually between dates, because a lot of times on the job you'll be asked to, or you need to look at some sort of results from first quarter of last year, and need to know like, okay, first quarter of last year would be between January 1st and March 31st. So then you would put those dates, where like sales date between, and then you would have January 1, 2024 and March 31, 2024. And then boom, that's how you get first quarter of the previous year. So you'll see that's where that tends to come in handy a lot. But you can use it on different columns too, like we just did with the age column. Then, like as promised earlier, let's go back to our select all query, where we were like, hey, we just want to see what's in the customer's table. Right? Now, and remember I was talking about, if you do that on like something that has 100 million rows in it with 200 columns, because I'm telling you, there's tables out there that these companies have produced, and the table got 200 columns in it. So it's a massive amount of data. So then you do this and you bog down the entire system for everybody. And that's not a good look. So to help avoid that, really, because you just want to take a peek at the data. You don't want to see all 100 million rows. That's going to take a long time anyway. You can do a limit. So I just want to see the first 3 rows. Select everything. So all the columns, give me all the columns, but I just want to see the first 3 rows. And that's how you can limit and not bog the system down for everybody, because it's not fetching the entire table. It's just literally getting the first whatever results that come from this query and just giving you those ones back. So vast performance difference there. And nobody's going to get mad at you for bogging down a system, because you're limiting your results as you should. Can you limit between? Let me think for a second. Not exactly. Like the limit is an exact count of rows you want returned, but maybe you want something where you've added a filter, but you also want to limit how many results come back from that filter. So like, let's say I wanted the 2 oldest people, period. So I would limit 2 because I only want 2 rows. What you can do is select, give me all the customers from the customers table, and then order by age, descending, because I want the oldest people first, and then limit this result to 2 rows. And then I get the top 2 oldest people. John Doe and Betty Doe are oldest people. So that's how you kind of like play with limits and filters and ordering and stuff like that. So if you want the oldest person, you can just do this. So you sorted the data so that the oldest person is at the top, and then you just grab that one row. So then, boom, here's your oldest person. So that's how you use limits. Any other questions there? One thing to note is not all database systems use limit, sadly. I think that's just because they, different companies create these database systems. So like, I think it's Microsoft where you, instead of limit, they have top 1 or top 10. So you write select top 10, and then you write the rest of the query. It's kind of dumb in my opinion, but because like, why make it different for everything? Like, why this can't just be universal? I don't know, but that is what it is. So It's key to, depending on the database system, where it's like Microsoft SQL Server or Oracle or Snowflake or something else. Definitely pay attention to the documentation and look up, look up how you can limit on that particular system. It may be this, it may be the top, it may be something else. I think Oracle has some rank thing that they have that's different than either one of those. So it just really depends. But typically, limit is like the one that gets used to limit the number of results you get back from a query. Okay, so this is really good so far. Let me know if you have any questions. I think it's a good time to take a break. We're like halfway through, and we got through the basics section, which that's what I wanted to do, was at least get through the basics section. So let's do like a 10 minutes if that's cool with everybody.
Great.
I think 10 minutes is cool. Okay, cool. Yeah, get some water, some
Yeah.
juice, take a leak. You know what I'm saying? So yeah, and yeah, we'll be back at 4:46.
All right. Sounds good.
All right, cool. See you then. All right. Let me give everybody a moment to come back. Get the music going.
You want to put the site right here in the chat?
The oh, you talking about the SQL site?
Mhm.
Yeah.
Has anyone used the site to try to code themselves? Try to code along, or y'all just paying attention?
I hope so. They yeah, that builds that muscle memory.
For sure, that's how I learn.
Mm-hmm. Yeah, you get to a point after doing it for so long, you get to a point you'll start typing and it's like you're not even thinking about it.
Yep. Guys, so I know a lot of you, it may be your first time doing this. So just wait until the recording is out on the YouTube and just follow along as you code using the sites. So make sure you save these sites, pin them, or whatever you need to do. Put them in your notes or something and refer back to them later.
Yeah, definitely save these. This programming site is definitely legit, because if you're trying to set up a local development environment to do this stuff, that's a headache all on its own. Trying to install a Postgres or a MySQL or Microsoft SQL Server or something on your own computer, then setting up everything, that can turn into a nightmare.
Yes, it can. We
Versus,
are, if we don't already, we are setting up a SQL server on the lab, so they'll have a chance to play around with it outside of this site too if they need to.
that's lit. Yeah, that's excellent that
We're
you're
doing
doing
a
that,
lot of different
because
things with it. We're actually going to be an MSP moving forward, selling IT solutions as products. But yeah, we have a mid server on there, so we're integrating different APIs, playing around and stuff, and just seeing what we can do.
that's fire.
Yeah, we got Linux. We got Linux, Linux environments, Kali environments. We have Windows environments, and yeah, it's a lot of new additions on there. But I'll make announcements about those later.
Cool, cool. Appreciate it. All right, I will resume the share. Let me know y'all can see. I got a question over the break about some stuff concerning limit. So There is Limit has an extra feature where you can limit the number of rows but offset on the results. So let's say you write a query, it returns 100 rows. And let me take this. We'll go over that in a moment, but let's say we're doing this, right? I ran this, I get 3 results. Let me also order by first name, so it'll be more visible. So Betty, David, and John are the first people to come back from this result when you order by name. And it makes sense. These are in alphabetical order. But let's say I don't really want these 3. I really want the last 3, or I want to skip the first 2 people. I still want 3 rows, but I want to skip the first two people. There is another keyword, this. If I'm doing this right, I should get David, John. I should get not these people. So actually, let's not do the order by. Let's redo this because this is hard to see. So let's do this. Okay, it's giving me back the customers in order based on customer ID. So that's how they are in the database. So it's giving me the first 3. But let's say I want the last 3, basically skipping the first 2. I want to say if I do offset, this gives me customers 3, 4, and 5. There's also a shorthand way of doing this where you don't need the keyword offset. You just put a comma. Okay, this gave me the last 2. So this is operating a little bit different. This isn't exactly offset. This is not something I'm showing this for exposure, but this is not something you see often. Out of all the queries I've seen over the years, I don't think I've ever seen someone do a limit with an offset. So it's not really something you should have to worry about too much, but I'm showing it so because, somebody asked about it, and I do like to just at least expose people to different aspects of stuff. So now you've seen limit, but you also seen limit and offset, and also the limit comma. Although I didn't really explain this one because I'm not even sure, because this is how much I don't use this. Like, this is doing something that's returning back 2 rows, and maybe what I think based on the results, I think what this is doing is saying with my limit offset 3, but give me only 2 rows. So it's skipping the first 3 rows and then giving me the last 2 rows. I can test that theory out and say I want to skip 1 row and give me 2 rows. Okay, yeah, that's what that's doing. So this says skip 1 row, give me the next 2 rows. Whereas this says give me 1 row, skip the first 2 rows. Okay. Hopefully that makes sense. If it don't, review the video, because this is something that exists, but I promise I have not seen this really used before for real. In the actual on the job. But I did want to at least expose you all to it. So now that we've gone over what I personally consider the basics. So select, we did a bunch of stuff on a single table, nothing too, outlandishly crazy, because queries can get outlandishly crazy with a lot of the logic that you can add. We're going to move on to a little bit more advanced topic of using functions and aggregating data. So still working on a single table at a time. Um, Hopefully, if we have time, we'll go over joins and stuff. But right now, we'll go over aggregation. So we'll we'll move on to another table here, selecting everything from orders. Right. So we have this orders table. It has some items, products, I would call them, and then an amount. So you could say that's kind of like in a price. I want to say this is like a price. We'll treat it as a price column. Okay. And then we have an ID of customer column. So that's kind of telling me like, okay, customer with an ID of 4 must have ordered a keyboard for $400. And this entire order has an ID of 1. So this is the unique identifier for this particular order. Then the next one has another identifier. Customer number 4 bought a mouse for 300 whatever dollars, rupees, whatever currency. And it just goes on. So in the real world, you can imagine like Amazon, this kind of table has millions, if not billions of rows, maybe trillions of rows over the years of all the orders that have been made. So yeah, this would be, a kind of a real world looking example of the type of data you would see at a business that sells stuff. Like physical products. So here, let's say we want to know, okay, out of all the orders, what does all this add up to? There is a function called sum, and you can run it on the amount column. If I run this 13,350 is the sum of all the amounts in the table. Now that's like, okay, yeah, what are my total sales? This is how you can get the total sales. And then of course we can go do our renaming, and boom, we have a result. Boom. So functions, there's a list of these. So you can Google it, documentation. I'll list them out in a comment here. So quick sidebar. I showed y'all the double hyphen comment. So that's one way to make a comment. The other way is to wrap whatever text inside a slash, asterisk, asterisk, slash. So like this means a beginning of a multi-line comment. And then this is the end of a multi-line comment. This is convenient because then I can do stuff like this instead of trying to, hyphen each line, because the hyphen only works on a single line. So that's why it's really convenient to have both of these types of comments, because sometimes it's like you just want to say something real quick, blah blah, but then maybe somewhere else you need to explain a bunch of stuff, right? So you have these multi-line comments. And again, the SQL editor is not going to try to run this as code. It's going to ignore this completely. But with that, I have a list here of some common functions. There's way more than this, but these are like the common ones. You might want to know the minimum, the maximum, the sum, the count, or maybe an average. But there's others. So I'll take that back out though. But going over aggregation. So this is like the most basic aggregation you can do, where it's like you're aggregating on a single column. So here, if I use the max function, This is the highest thing, the biggest amount that was sold in a single order. And we see the 12,000, which that makes sense. 12,000 is the biggest number. What was the cheapest thing, or how much was the cheapest thing? The cheapest thing was 250. The cheapest order was 250. So you can use those orders. Now we can look at count. So count is just literally a count of the rows in the result after all the filtering and all that stuff and meeting whatever conditions. So right now I don't have any conditions. And you can also use our shortcut of all. So this is saying count just whatever rows are there from this table. Just count all of them, right? And I don't have to give it this name. That name doesn't even make sense anymore. So I'll run that. This is telling me that the orders table has 5 rows in it. Period. That's what count is. Now, if you, in this particular sense, you don't have to put star. You could put item. It'll give you the same thing because there's 5 values in the item column. So, but typically you'll see this. You'll see count all, and you get how many records are in a table. What's usually used in conjunction with these functions, and these are really called aggregate functions, is that you will call out a column first. Now, the column, you could call a column out before, you could call it after. That the ordering of the column is up to you. But typically you see like, okay, give me all the single things, and then at the end do all my aggregations. That's kind of how people tend to write it, but there's no law saying you have to do that way. So here we're saying basically select item, count all. When you do this, this is going to add up. Like, we have keyboard in here twice. So the result is going to say have keyboard once, and then it's going to say how many times it occurs is 2 times. So you get a single row for keyboard instead of 2 rows because you're counting the rows. That's aggregation. So when you do aggregation, you have to include another keyword, which is group by. With group by, all you're doing is including all of the columns except the ones, everything in the select statement except the aggregate functions. So here we just have item. Let's run this. So what this did was it counted how many times keyboard occurs twice. The rest of them occur 1 time each. That can be, this is something that's done a lot. Like we have some sort of category and we want to count how many occurrences of something happening in that category. In this particular case, what would be more informational would be summing on the amount. So I want to know, okay, how much total orders, what's the total order value for keyboard, for mouse, for monitor within this table? For keyboard, I'm expecting to see 800 because it should add up to 800 just for keyboard, and then these numbers for the rest of them. So I run that and look at that. We can also call this sales. So now we have a aggregation on the amount of sales per item, and you end up with like a unique list of items instead of seeing the item duplicated more than once. So that's the beauty of the aggregation. This is where you're basically starting to do analysis on the data by using these aggregate functions and trying to see, what's going on in your data. So this is like Aggregations are like the beginning of data analysis. But when you do aggregates, again, you need to add the non-aggregated fields in the select to the group by. So like if I added customer ID, so basically I'm saying for every item and the customer that ordered that item together, that makes a group and give me the sum of the sales. And matter of fact, let's run this as is. It gives me an error because it says no such column costume. Oh, it's spelt wrong. Okay, let's do that. Straight missed that all the way up. Okay. So this ran, and again, this is a particular system thing. It didn't call out that, hey, there's no group by. It just ran and it gave me some result. I'm not sure if this is the result I actually wanted, but Microsoft SQL Server or Oracle or Snowflake, those won't be as forgiving. They can give you an error. They will give you an error. Something not included by a group by or whatever, some sort of error like that. So basically what I tend to do is I'll write all my single columns out here, then do all my aggregations. My children are loud, but that's okay. Hey, CC, close the door. All right. So you sum up you put all the aggregates in the later part, and then I just copy paste the non-aggregate columns into the group by. So I run this and see this. So by adding that, you see I got five results because basically the item and keyboards, each of these ended up being unique. So customer 1 bought a keyboard and customer 4 bought a keyboard, and they ended up being unique. So you don't really get the aggregation. But let's say customer 1 bought 5 keyboards over the course of 3 months. Maybe he runs some sort of business or she runs some sort of course or whatever. So they're ordering multiple keyboards. You would see that in here because it would be like 20,000 in sales on keyboards for this particular customer. But you would see all those as individual entries in the table. Does that make sense? Any questions here so far? Okay, so now let's say stepping back and just going back to functions in general. There's a real interesting thing you can do with count and the other ones too, but like oh, you know what? Did we not go over this? Did I? I totally forgot to go over this. I'll go over it now. There is a keyword called distinct. This is useful when you just want to see, okay, how many different categories are in this column, especially in a column that the categories repeat a bunch of times. So like maybe it's 10,000 rows in a column, but there's only 100 distinct like categories to choose from, or 10. And you just want to see though what those 10 are. You can use the distinct keyword for that. Okay, we got a question. You can also group by 3-2 instead of the actual column name, correct? Yeah, usually that works. You can reference the column by its number position, that its positional number in the select statement. So let me do that real quick. So order ID, item, customer ID, sum amount from orders group by 1, 2, 3. This should just give me the whole table back. But yeah, all this is saying group by one. One is order ID, two is item, and three is customer ID. What this does is it saves you on typing. Do it. My suggestion on using this syntax is use it like when you're trying to do some stuff to understand the data and stuff like that. But if it's like a query that's going to be used by other people, write the names out. And the reason I say that is because sometimes these can be, right now it's just 3 columns. But if it's 20 columns and the aggregate functions are sprinkled in between the 20 columns, this way of doing it can get really hairy and really hard to read. But this does work. So you can do that in a lot of SQL systems, is reference a column by its number within the by its position in the group by statement. But yeah, so going back to the distinct keyword. So you might have a bunch of rows where a certain column has a certain category and you want to see what are all the values of that column. Like what are the set of unique values that column has. So if I run this tells me, even though this table has 5 rows, it's only representing 4 items because keyboard appears twice. And it would, if this table was bigger, I'm sure all of these would appear more than once because you got different people ordering the same item or the same person ordering different items in a separate order. So the distinct is a way to like grab the actual unique distinct things from a column. And you can mix these up. So it's not just on one column, but you can do the amount. So basically this probably represents what's in maybe a product table that lists out all the products and their prices. So the keyboard is $400 period. The mouse is $3. The monitor is $12,000. The mouse pad $250. Like period. So this is just a way to get your unique thing. What you can also do is if I count not keyboard, item. If I count item, that just says how many rows have a value for item, 5. You can also do this, count distinct. This is a useful thing. You come across this on the job, where it's like, okay, I want to know how many distinct items, like, because maybe you don't care about what they are yet. You just want to know how many distinct things there are. And there are 4. There are 4 distinct products or items that reoccur in this table. And then you can also, add that to you can add that with other columns to basically do an analysis that you may need to do. Another example would be the status on the shippings table. So if I do this, I know we haven't looked at the shippings table yet, but looking at this, at a glance, you can see data set small. We have 3 pending and 2 delivered. So what I expect is there's 2 distinct statuses that you can have. Run and boom, it tells you there's 2 distinct ones. Then if I want to actually see what they are, select distinct status from shipping. Then we get the pending and delivered and boom. So this is a way to like do queries on a data set so you can kind of understand what's going on in the data. Like this is a category. It has 2 things and the 2 options are delivered and pending so far. There could be others, if it was a bigger data set or whatever. Now, going back to show more about how to use or what you can different things you can do with aggregate functions, right? Let's say we're looking at the customers table, and maybe two people have the same name. We'll take last name, for instance. No, better yet, first name. First name. We got two people named John. We know that from looking at the data earlier. And we could write a query like this. Select first name. And we want to get the max age from that group of names. From customers group by first name. And we can also order by an aggregate function. So order by max age. We can do this. Run this query. And as you can see, out of people named David, the oldest one is 22. Out of people named Robert, the oldest one is 22. Out of people named Betty, it's 28. Now, for these three people, they only occur one time. So we can just see their ages straight up. But John, we got John with the age of 31. There's two people with the first name John, 31 and 25, and it took the max value between 31 and 25 and returned that to us. So that's what's happening here. If we do last name, we see that, we have Doe 31. So we got two people with the last name Doe. So it picked between 31 and 28 and gave us the max age. You don't have to do the order by either, but that tends to be a thing where you can, you just want to have your sort. Matter of fact, let me go back to that, and we would want to see it this way. The oldest person at the top, the younger people at the bottom, out of people with the last name Doe, 31. Any questions about that? Let's see. Now here's a superpower of doing aggregate functions. There is another keyword called having. Now, before we talk about that though, let's say you want to see the max age, but you don't want to see everybody's max age. You want to see the max age above 25. Normally, you would do where age greater than equal to 25. I think this is going to work. Yeah, that works just fine, right? It makes sense. We're only looking at people older than 25. So you're going to, before you even do the aggregation, you're going to get rid of everybody that doesn't make this criteria, that doesn't meet this criteria. But there is a more straightforward way using having, where you can write, hey, I want to, pick all the max ages from everybody, and then say that having the max age greater than equal to 25. This was made in SQL because you can't do this. But watch it work on this system though for some reason. I will comment this little piece out. So It didn't work. This is good because this, you can't do this. You cannot put a aggregate function in a where statement. Misuse of aggregate. So having was created for this. And I'm just going to put another thing in here because I want to highlight something real quick. If you look at this query in its totality, you see this shows the order of all the keywords that you can have. So we got select, from, where, then group by, then having, then order by last. So this is like the order of how you have to write SQL. The white space doesn't matter. Again, all of this, I could have put all of this on the same line, but who the heck wants to read that? Everything is on a different line, basically starting with the keyword though. And yeah, it's this is the ordering of the keywords in the operation. Select, from, where, then group by, having, and order by. Yes. And if you're going to do limit is down here. So yeah, that's like the final of the SQL keyword hierarchy, basically in the order of how you have to do things in. Let's do another example. Going back to our orders. So like, let's say we want to see the top most expensive items over a certain amount. So we can select item, max amount, from orders, group by item. All right. Having a max amount greater than 500. Matter of fact, let's do greater than equal to. So it got to be at least 500 for the total sales, right? Because maximum or the highest price, it's only one that meets that criteria, which makes sense. Everything else is under 500. But yeah, that's how you use having. This is aggregate filtering. So you have a aggregate function and you want to filter on the values produced from that aggregate function. You use the having keyword to do that, and that goes after the group by. Group by goes after where. Unless you're not using the where, then you just leave it out. Any questions about that? So we technically have 5 minutes left for the official time, but listen, it's a free thing. It's laid back. You know what I mean? If we want to spend an extra few minutes, I'm okay with that to go over the next topic, which is really the ending of what I wanted to accomplish with this free course. So we went over those basics.
Yeah,
Say what?
I was gonna say everyone give a thumbs up if you want to stay for the last topic. I don't mind. I think we should. And then if anyone needs to drop, they can, and it'll be on YouTube for them. We got
Yep. Cool.
Sounds good. All right.
Cool. Appreciate it. Yeah, somebody said, are we going to continue to have access to the online SQL editor? So check this out. This is not my site. This is there's some other company that maintains this site, but they just have it up here for free. So yeah, you can always just go back. It's been here for years. I've used it for years. So yeah, you can always go back. I'll do this right now where let me see, where is my repositories? you can go also look through this repo. And I'll make updates as necessary, but like basically these are the topics that we went over today. So you can come in here, grab these queries and copy and paste them, run them in this editor to try to go back over and understand things. So I'll put them all in here. And there's some extra stuff in here like unions. We're not going over unions today. Then just some mentions of some advanced topics. Basically, you come in here, you see this stuff, go look this stuff up, and then you find examples. I may be adding, stuff to this later on. Just not at the moment. Just getting started with this free course thing. So, as I think of stuff, I'll add it here and then push it up, and then you'll be able to see it in the GitHub repo. So, yeah, let's set up part 2.0. I know, right? Yeah. I'll work on something. That might be like a YouTube thing or something rather than a in person or a Zoom. But I definitely like going over the basics because I want people to be able to ask questions about the fundamental stuff. Then once you have that down, it's easier to move on to like the more advanced stuff like subqueries and stuff because you have a good grasp on the basics. So yeah, we'll move on to the last piece of this. Basics of anything's always key. That's yes. When you got the fundamentals down, the advanced stuff is a lot easier to digest for sure. I am going to now show you. Well, I'll present a problem. So, with this data set, let's say this is a real company, and we have orders in here, and we have customers. But if you look at this orders table, it just says, okay, customer number 4 ordered 400 keyboard for 400 ordered keyboard. Okay, but we don't know who that is, but we do, right? Because it's in the customers table. These two columns relate these two tables together. And that's the real power of SQL, is that you have a relational database because the tables in the database are related to each other somehow. In this case, we have a table of customers. Each customer has a unique ID. So we can refer to this instead of trying to put the first name, the age, and like all of that and store it in the table again. We want to minimize duplication, right? Because storage isn't free. It's really cheap, but it's not free. So it's best to have a identifier for a customer. So customer number 1 is always John Doe, that's age 31 from the USA. And when he orders something, his ID is written in the orders table instead of all this extra stuff. But okay, what if we want to do a query to get this stuff back? That's where joins come in. That's you joining two tables together to combine the information between the two to give you something back that's useful to you. So I'm going to join the customers table and the orders table together to give me back. I want the first name, the last name, what country, what the item was, and what the amount of that item was, and put that all in one single result set. So if I just do this just straight up, when you're joining tables, sometimes the two tables can have the same column name and you need to differentiate. So like this has customer ID, but this is also customer ID. So you want to know, are you referring to customer ID from the orders table, or are you referring to customer ID from the customer tables? So what we do is when we write the column names, you write the name of the table first. Customers dot first name. Right? Then I said I wanted the last name. Then I wanted the country. Then from orders, I wanted the item. And from orders, I wanted the amount. And then I'm going to do what's called an inner join. And I'll pull up the different types of joins in a minute. But an inner join, just real quick, is like you're going to match up only where what you're joining on has a match. If it don't have a match, then leave it out. If it does have a match, include it. So like a 1 and a 1, 2 and a 2. There's no 5. There's no customer ID 5, so there won't be a row for customer ID 5 because customer ID 5 didn't order anything. Wait, we don't do that first. We do from, select from customers, and then do your inner join. Inner join, and then the table, orders, on, and now we want to say, this is where we make the relationship, tie the two tables together. Customers.customer ID is equal to orders.customer ID. And we'll order by customer ID from the orders table. So I just did a lot of typing, but this is the query. We got to select, we got our columns. We're calling out, okay, this column comes from the customer table. This column comes from the order table. These are the two tables. We're joining them together on this column. So that this column has values that's supposed to match this column in this table. And then we're ordering by the orders column the customer ID column in the orders table. Run this. And now we see, hey, John Doe bought a keyboard, and so did John Reinhardt. John Reinhardt also ordered the mouse. David Robinson balled out and bought the monitor. So like now this is more useful information for a human reader. Like this is good for the machine. It's efficient. But now we've embellished this, and of course I can go in and add all the, let's call this first name like that. Last name like that. Try to make it more pretty, whatever. So yeah. So far, any questions about this?
When just a quick question. When you instead of doing that entire thing, you can do the um the from as, right? You instead of saying like order
Yeah,
item, you can do as customer as C and inner join order as O, and then you instead of writing customer last name, you can write C dot last name, C dot
absolutely.
country, order O dot item.
Absolutely. So yeah, that's the very next thing. So I mentioned I did a lot of typing. You don't have to do all this typing. And you can still, refer to the right thing from the right table using aliases. So remember earlier we had the as keyword. So instead of just saying from customers, I can do from customers as C. I can do from orders as O. And then put C here. And then put O here. C here. O here. Oops, not 0. O. And then O here. Run this again. I get the same exact result because now I have aliased customer table as the letter C. And of course you can call these aliases whatever you want. I could have maybe did that right. So it's a little bit more, it communicates to maybe somebody else who's reading this query that, hey, this is customer. Run this again, same thing. Oh shoot, I forgot one. Down here. Same result. So you have that freedom and flexibility. You don't have to do all that massive amount of typing I did. But I wanted to show you that because of what to drive home what aliasing does to help you. So yeah, you cut down on like a whole lot of typing and increase, in my opinion, increase some of the readability of the query by shortening the name to this. Also, another thing is enter, the word enter here is typically optional. The default join when you use the join keyword is an inner join. So we can take that out as well, run this, and we still get the same thing. So this is where the real true power of SQL really starts to stand out, is when you got these different tables and then you can start joining them together to get data that makes a lot of sense. And then just to make it more relevant, you can you do this type of stuff so you can get a data set that can be put in a report or get fed to the data scientists so that they can create a model and train a model off the data, or use a model to run against that data to get some sort of other kind of insight, like, oh, John Doe is likely to spend again within the next 3 months $8,000 or whatever, or we should market to Robert the mouse as well, since he bought a mouse pad. Like maybe there's some algorithm that or machine learning algorithm that fleshes that out. So like this type of query is where that comes into play. When does left join come into play? So depending on the situation, a lot of times we need to do a different kind of join instead of an inner join, because an inner join, you don't necessarily get all the data, because like I said, if there's not a match, you won't get a row, because the customer IDs, the customer ID might not exist in both tables for that particular order or for that particular customer. So you won't see that. But sometimes you might need to know what's there and what's missing. So there's different kind of joins. If we do a search on SQL joins, this is an image that comes up quite often. This is going over all the different kind of joins. So table A, table B, an inner join, only stuff that matches. That's it. A left join is when your main table, you want to keep everything, but you also want to include stuff that matches from table B in the result. So you get all the results from A and then whatever matches from B. For the rows in table A where there is not a match with B, you're going to get null values. But that's okay, because then now you're saying, okay, I see that customer 17 never ordered anything. They're just an account in our system, but they've never placed an order. And a left join would show you something like that. Right join is basically the same concept, except how when you look at how the query is written, the table that is written in the from part is the table that's on the left. Then each join is like setting a table to the right side of the first table. So with a right join, it's saying, okay, include everything in here, but just write null for stuff that doesn't match from the customer table. Outer join, this full outer join, this is give me everything from both tables where they match or not. So you'll see the things that match. You'll see customers that didn't make an order, but you'll also see products that have never been ordered. So that's what you're getting, like the full thing right there. This is strictly customers who never ordered anything. So they exist in the customer table, but they have none of these match with anything in B. So these are customers who never ordered anything. They just sit in the system. This is orders. This is a right join, right excluding join. This is saying, okay, this is all the products that have never been ordered by a customer. This is products in our warehouse that nobody wants, basically. So that's valuable information. This is both of those together. Customers who never ordered anything, and then products that have never been ordered. But it's all in the same result. So like you have a bunch of no's over here, then you go down, and then there's a bunch of no's on the other side because the products haven't been ordered. And those are all the types of joins. But again, this has been hashed and rehashed. There's a lot of information about the basically, what is this? 7 types of joins. So you can go research that. But yeah, typically the 2 main joins that I've come across in industry is doing inner joins and left joins. So you start with a base like data set, and then you're adding things to it. So you want to keep the original data set, and then you're checking to see, okay, what matches, what doesn't match by joining up the other stuff. Or you just only care about what does match. I hardly see any right joins, and then I hardly see any exclusionary joins. The only time I've seen that was during, I worked at a bank one time, and we wanted to see like who didn't pay their credit card off or something like that. Who didn't pay their credit card off every month, and you could filter out that type of information using those exclusionary joins. So it really depends on the situation, but the most common is the inner join and the left join. Also, with these joining, with joining the different data sets, there's different kind of relationships. There's 3 different kinds of relationships, basically. There's the one-to-one. So when the customer table, there's one unique customer per row, period. But you could also have another table that's not a customer's table, where it's a one-to-one, where it's just one customer per row, period. Like there's no duplicates of customers in that other table. So then when you join those 2 tables together, that's a one-to-one relationship. Now, between the customers and orders table in this example, we're looking at a one-to-many relationship. So we see John Reithart's name in the customer table once, but if you look at this join we just did, we see his name 2 times. So he ordered 2 things out of the orders table. So that's a one-to-many relationship. Then there's a many-to-many relationship. Now, many-to-many relationship, let's say that you have a school table, and then you have a students and courses, right? So you have multiple students and multiple courses. So more than one student can take more than one course, and you get this kind of like mix and match of students and courses, where you end up with a many to many relationship. So many students can take one course, or many students can take the 2 courses, and one student can take many courses. So it's just many to many. So it's like think of that the mix and match stuff we used to do in elementary school, where you got stuff on one side, you got stuff on the other side, and you draw a bunch of lines between them to match them together. It's kind of like that. So many relationship. The reason to understand those 3 types of relationships, because it'll help you draft the query that you need, and help you understand, like, okay, if I join these 2 tables, I know that I can get a larger data set because it's many to many. And you want to be aware of that, because again, you don't want to bog down the system, and you want to do all your filtering and calculations a certain way based on the many to many. Now, what you do exactly is, that's a more advanced topic. That's a 2.0 type of topic. But yeah, this is how you do joins. There is a such thing as this. So this is a explicit join. I'm only gonna show you the explicit join. The implicit join is a thing, but like it's less clear what's happening. And when you start to, if you do a if you do an implicit join on like more than two tables, the query itself starts to look crazy, and you don't want to do that. I like doing this because, and I will strongly encourage everybody to do explicit joins because let's say now I want to join shippings, right? It's just add another join. So you add a join like that, and also the as keyword again. That's optional, just like it is up here. It's optional, but down here too. And so I want to join shippings S. What is the relationship here? We have shipping ID and we have customer. This looks like customers IDs. They just called it customer because it doesn't necessarily, the relationship column doesn't have to have the same exact name that it relates to in the other column. There's no rule saying that. So from the shippings table, we can grab customer, and then from the customer table, we get the customer ID. And let's say we want to just add, well, what is the status of that person's order? And again, this is an inner join because that's the default type of join. We run this. Now we've added status. So we know that John Doe's order has been delivered. David Robinson order been delivered. Everybody else order is pending. Matter of fact, I think it'd be more beneficial to do s.status. Order by that so that the statuses are next to each other. And we can see all the delivered stuff and we can see all the pending stuff. Any questions there? You can also do the same stuff we did earlier on the basic stuff. So we can add a where clause. Let's say we only want to see stuff that's been delivered. Well, we can just add a where. Run that. Now we only got the two rows where the stuff is delivered. So hopefully this shows like how powerful SQL can really be once you start really like understanding the data that you're looking at, and then all of the options that you have for writing a SQL query and why this is like a good thing to know. If y'all are good, I'm good. Y'all have any other questions? If you enjoyed this and feel like you learned something, let's see a reaction, thumbs up, a clap, something. Cool, cool, cool. I'm glad. I really wanted this to be helpful. And so yeah, that's kind of telling me that yeah, this has been helpful for you all. And again, we're gonna have the recording available. I think they put it on Twitch, like so
I
it's
tried to get it on
resources
Twitch,
available.
but it was some technical difficulties, but it will be on YouTube, and I will be tagging Chris and everything, so you'll be able to get in touch with everyone that you need and see the replay.
Awesome, awesome sauce.
Thank you so much for doing this for the community. We definitely appreciate you and all your time and effort that you put in this.
Yeah, you're welcome. And yeah, I'm definitely going to be doing it again. It might be next month, it might be May. I don't know. But I'll communicate that, you know what I
Yeah,
mean?
it's
So
fine. Again, you guys, we need you to fill out that survey. It's in the chat, and also it's now in the oops, wrong thing. It's now in the
yeah, I'll
Discord
post that
channel
link
as
too.
well, in notes and resources, so you can find it there. And then I'll just repost it here again, so you don't have to go
And
and
then
find it.
Yep, awesome. Yeah, and then we'll have the links and stuff to the like the GitHub and stuff too in the Discord. And you know what? I also everybody who signed up on Eventbrite, I'll email the stuff too, so you'll have it there. So yeah,
Great.
all right, I'll stop this. But yeah, thanks for everybody signing up and attending. This has been good. I had fun. So yeah, we'll see y'all next time.
All right. Bye, guys. Thanks.
All right, see you.